Ever wondered what polymorphism is in programming? Well, today we're going to unravel the mystery. Polymorphism is one of the 4 fundamental principles of object-oriented programming, along with encapsulation, inheritance, and abstraction. But what exactly is it? In the simplest terms, polymorphism allows objects of different types to be treated as objects of a parent type. Imagine you have a set of shapes, a circle, a square, and a triangle. While all these shapes are different, they are all still shapes. This is the essence of polymorphism. Each shape can be treated as a generic shape, yet each also retains its unique properties. This principle extends to programming, where different objects can all be treated as the same type. It's like having a universal remote that can control a TV, a radio, and a DVD player, even though they're all different devices. So in essence, polymorphism is about one name, multiple forms. But how does this work exactly? Let's delve deeper. First off, we have static polymorphism, also known as compile-time polymorphism. Now, what does that mean? Well, it's quite simple. Static polymorphism is determined during the compile time, not at runtime. It's like deciding what to wear for the day in the morning itself, rather than changing outfits throughout the day based on the weather. A perfect example of static polymorphism is method overloading. In programming, you can have multiple methods with the same name but different parameters. The compiler determines which method to use based on these parameters. It's like ordering coffee. You can have an espresso, a latte, or a cappuccino, but they're all coffee. Another example is operator overloading. This allows operators to have different functionalities based on their operands. Think of it like the plus operator. It can add 2 numbers or concatenate 2 strings. So that's static polymorphism for you. But that's not all there is. Next up, we have dynamic polymorphism. Now, let's turn our attention to dynamic polymorphism, also known as runtime polymorphism. This variant of polymorphism occurs during the execution of a program, not at the compile time. It provides the ability for a call to a member function to be dynamically resolved based on the object type. A popular example of dynamic polymorphism is method overriding, where a subclass provides a specific implementation of a method already provided by its parent class. In simple terms, it's like a child taking after a parent, but adding their unique twist to inherited traits. Take, for instance, a virtual function. This function is declared within a base class and is redefined in a derived class. With dynamic polymorphism, the function to call is determined at runtime by the type of the object pointed to, not by the type of pointer. So, consider a base class shape with a virtual function draw. If circle and square are derived classes that override this function, the correct draw function is invoked based on the object type at runtime. And that, in a nutshell, is dynamic polymorphism. But why does all this matter? Let's sum it all up. So, why should we care about polymorphism? I'm glad you asked. Polymorphism is not just a fancy term for programmers to throw around. It's a vital cog in the machinery of object-oriented programming. It brings flexibility to the table, allowing us to use one entity in multiple forms, hence the name poly, meaning many, and morph, meaning forms. Consider it like this. You have a smartphone. You use it to make calls, send texts, browse the internet, take photos, and so much more. That's polymorphism in the real world. In coding, it's similar. A single function or an operator behaving in different ways in different instances increases reusability of code, thereby enhancing efficiency and productivity. It's like having a Swiss Army knife in your programming toolbox. One tool, multiple uses, that's the magic of polymorphism. And with that, we've demystified polymorphism. Remember, it's all about one name, multiple forms. Until next time, happy coding!